Right?
Okay, so you get better measurements. Is there anything that a customer could do with the system that is running with that data? Can they change the way that they're charging, or something to that cell specifically, or?
Yeah, for example, what it's becoming more and more popular is trying to balance your battery using the state of charge of each cell.
Okay.
What does it mean? Well, first of all, what's cell balancing? Cell balancing is when you have, for example, one cell that has more charge than the other cells.
Okay.
You want the battery to be like equalized, the same charge in every cell.
Yep.
Right? So what people used to do is they use voltage, right? So they use the voltage for a balance, for decide which cell has to be balanced. But using the state of charge is a better way to do it because every cell has different capacity, right? So with the state of charge, you ensure that all the cells are at the same state of charge, which does not mean that they are in the same voltage level.
Yeah.
So using the state of charge really gives you more range, for example. It gives you can use the battery longer if you balance using the state of charge rather than using the voltage.
And so when you're doing a cell balancing, does that, are you able to do something, or are they able to do something at a cell level, or does that mean they know that the capacity, like when they're charging, what the actual capacity is on charge and what the capacity is on discharge? If you have one cell, it, let's say, is a little bit higher or lower, what can they do?
When, for example, if you are charging, usually you charge using passive balancing when you're charging, which basically you burn capacity for the cell that has the higher capacity, and you try to equalize the pack, right?
Okay.
That's the method. So you equalize this in terms of voltage, but not in terms of state of charge.
Okay.
Right. So doing this using the state of charge would mean that if all the cells has the same state of charge, the battery pack will have like the exact same state of charge. Right. You are not you are charging every cell with the maximum available capacity that it has.
Okay.
But if you do it with the voltage, it may not happen.
Okay, because you might have some cells that have a little bit higher voltage, or can. So how, when they're doing a cell balancing, let's say you have one battery, one cell that is, let's say it's performing worse than all the other ones. Is there something that can be done to optimize that pack, or are they just stuck with, they have one cell and so the whole pack can only be used up to the capacity of that one cell?
Yeah, for example, if you see this behavior, maybe one cell is like above the in terms of voltage than the other cells.
Right.
So it may reach the over voltage threshold before the other cells.
Okay.
That means that you are not really, like, the battery pack is not really charged.
Because it's limited by the one cell.
It's limited by this one cell.
Right.
So using this balancing, you can put all the cells at the same charge level using the state of charge. So when it reaches the over voltage, all of them will reach at the same time. Like all the cells will be 100% charged.
Okay.
Right. Which
maybe I'm not understanding like one a basic thing. So is like the analog front end able to switch off charging to specific cells? So you could charge up the pack. If that one starts to overvolt, then does it just get disengaged, or what's the right way to think of that?
Okay, that's an interesting point, because we enter into the two different kinds of balancing. We have the passive balancing, as I told you, that was you discharge all the cells that are over a certain threshold, but you discharge them. You cannot charge them. You are burning current.
So you're doing, on the discharge, you're turning different cells on and off based on the capacity of that cell, the state of charge of that cell. Okay.
Yes. Okay. And then you have the active balancing.
Okay.
The active balancing is a totally different, totally different thing to do.
Okay.
You can basically move, or you can move charge from one cell to another cell.
Okay.
Yeah,
Yeah.
actively.
Okay.
So maybe if you are discharging and you see that one cell has less capacity than the other one,
Right.
you can pass this capacity to the other cell.
Okay.
Right?
Okay,
So
yeah.
this, for example, is really, really important in a very big battery packs.
Oh, sure.
Because it's very complicated to balance, like passive balance, because passive balancing, you are using a simple resistor for
really?
burning
Okay.
capacity,
Okay.
right? But if you do this with 2-3 amps,
Right.
that's, I mean, you are going to need a really big resistor
Burn it
resistance,
up.
right? Yeah, because it will blow up otherwise. But with the active balancing, we can achieve 3-4 amps of balancing current,
Okay.
and we are like distributing all the charge like of the
Okay.
battery, so we can do it like equalize all the battery actively.
And so is active done on discharge and charge, or
Yeah, it can be done both.
in either direction?
Yeah, in passive balancing, we don't usually do it in discharge because
okay.
you are burning capacity.
Oh yeah,
right?
yeah, yeah.
So you don't want to
you don't
really
put
like
a resistor and heat things up.
Yeah,
on
heat
your-
things up
when
and
you're- yeah.
you lose, like
Okay.
let's say, yeah.
Okay. So with the example of active balancing on charging, if you have one, let's say one cell that's lower performance, so all the other cells reach full state of charge.
Yeah.
So yeah, state of charge is full. And you have the one cell that maybe is a little bit low.
Yeah.
With active balancing, you can continue to charge that one cell.
Yeah.
Is that the right idea?
Yeah. You
Okay.
could
Okay.
send like charge to
Okay.
this cell. Yeah.
Okay. And with state of charge known on every cell, with our system, it
Yeah.
allows that to
allows
occur.
that to do it more accurately
Right.
because every cell will be fully charged at 100%.
Perfect. Yeah. Okay. Okay.
Otherwise, if you don't know the cell, individual cell state of charge, you cannot do that.
Right. And you run the risks of, you have to, I suppose you have to, if you don't have accurate measurements, you have to have some kind of threshold below your max,
Yeah.
so you don't overshoot, you don't because otherwise you have, you damage everything. And
Yeah, and if you do it like the old way, you are losing like some range, right? If you do it with this state of charge method, you will increase the range of your battery, and you will also probably it also ensures like the battery will live longer because every cell will age at the same time.
Okay, yeah, so you can correct instead of undercharging everything because you have one bad cell, or overcharge. Well,
It will age more equal.
Okay. Okay.